हॅलो. आपण कालच पाहिलं की एनर्जी कॉन्झर्वेशन थेरम आणि एक्झाम्पल पण पाहिली. आज आपण एक महत्त्वपूर्ण एक्झाम्पल पाहणार आहोत. तर एक्झाम्पल तसं भास्ट पण आहे. अगदी थेरी एक्झाम जर तुमची थेरॉटिकल जर असेल तर 15 ते 18 मार्काला क्वेश्चन्स येऊ शकतो. हमखास असा नाही म्हणता येत पण तो येऊ शकतो. Find the velocity dependent potential and hence the Lagrangian for a particle of charge q moving in an electromagnetic field. Now see here, consider a charged particle. बघा, velocity dependent potential, find the velocity dependent potential आणि Lagrangian for a particle of charge q moving in an electromagnetic field. तर आपण एक पार्टिकल चार्ज कन्सिडर करायचा आहे आणि त्याची वेलोसिटी सपोज दॅट v इन अन इलेक्ट्रिक फील्ड ई बार अँड मॅग्नेटिक फील्ड बी बार, दोन फील्डमध्ये असणार आहेत. आणि मग त्याच्यामध्ये जो फोर्स ॲक्टिव्ह होतो तर त्याला त्या फोर्सला लॉरेंज फोर्स असं म्हणतात. बघा, कन्सिडर अ चार्ज्ड पार्टिकल ऑफ चार्ज q मूव्हिंग विथ इनिशियल वेलोसिटी v इन अन इलेक्ट्रिक फील्ड E bar and magnetic field B bar. Then the force acting on the particle is called Lorentz force and is given by F bar is equal to Q E bar plus V bar cross product B bar, where E bar and B bar are electric field and magnetic field respectively, and it satisfied Maxwell's field equation. मॅक्सवेल फील्ड इक्वेशन काय आहेत बघा, तर डेल डॉट प्रॉडक्ट बी बार, डेल्टा डॉट प्रॉडक्ट बी बार इज इक्वल टू 0 अँड डेल्टा क्रॉस ई बार इज इक्वल टू मायनस डो बी बार बाय डो टी, असं मॅक्सवेल फील्ड इक्वेशन आहे. ठीक आहे. तर पहा, आपल्याला एक आयडेंटिटी माहीत आहे आपल्याला. तर ती आयडेंटिटी कोणती आहे, तर वी नो दॅट अ वेक्टर आयडेंटिटी डेल डॉट डेल्टा डॉट प्रॉडक्ट डेल्टा क्रॉस प्रॉडक्ट ए बार इज इक्वल टू 0. Therefore, Maxwell equation imply that there exists the magnetic vector potential A bar, which is functions of coordinates and velocities, such that B bar is equal to delta cross product A bar. Now the value of B bar, substituting in del cross E bar, here minus and take LHS, therefore plus do B bar by do T. Therefore the value of B bar is equal to del cross product A bar, substituting in del cross E bar plus do B bar by do T. Therefore we get the expression delta cross product E bar plus do by do T of delta cross product A bar is equal to 0. Now in both quantity Delta is common, therefore delta take outside common throughout cross product. Therefore delta cross product E bar plus dou A bar by dou T is equal to 0. Call equation number. Then also we know that vector identity delta cross product delta phi is equal to 0. Now equation 4, delta cross product E bar plus dou A bar by dou T is equal to 0, and equation 5 what is delta cross product delta phi is equal to 0. In both cases delta cross product same here. Therefore we know the vector, we see that there exists a scalar potential phi which is a function of coordinates and not involving velocities, such that E bar plus dou A bar by dou T is equal to minus delta phi. We evaluate the value of E bar, electric field. E bar is equal to, now see here, minus delta phi minus dou A bar by dou T. Equation 3 and 6. Equation 3 what is? This is B bar is equal to delta cross A bar. This is equation 3. Equation 3. And equation 6, delta E bar is equal to minus delta phi minus dou A bar by dou T. This value of B bar and E bar substituting in one means Lagrange force. Therefore F bar is equal to Q minus del phi minus dou A bar by dou T plus V bar cross del cross A bar, delta cross A bar, where we have delta phi is equal to I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z, and dou A bar by dou T is equal to I dou x by dou T plus j dou A y by dou T plus k dou A z by dou T. Therefore del cross product A bar is equal to determinant of, we know that from base 4 second, gradient of the functions we have calculated already. Therefore delta cross A bar is equal to modulus of determinant of I j k dou by dou x dou by dou y dou by dou z, and solving this determinant we get I dou by dou A z by dou y minus dou A y by dou z. Rules of the determinant minus j dou A z by dou A z dou A z by dou A x by dou z minus dou A z by dou x plus k dou a y by dou x minus dou a x by dou y, and this is equal to v bar. Now in addition to v bar cross del cross a bar, now we have to determine delta cross a bar. Delta cross a bar nothing but this value, this, and v bar I j k, v bar vx, vy, vj. Therefore in second row of the determinant vx, vy, vz, and remaining them here dou a y by dou x, dou a y by dou x minus dou a x by dou y, dou a y by dou x minus dou x by dou y, dou a z x by dou z minus dou a z by dou x. Therefore cross product of v bar cross delta cross a bar is equal to I vy dou a y by dou x minus dou a z by dou y minus vz dou a z by dou z minus dou a z by dou x plus j vx plus j vx dou a y by dou x minus dou a x by dou y minus vz dou a z by dou y minus dou a y by dou a dou z plus k vx dou a x by dou z minus dou a z by dou x minus vy dou a z by dou y minus dou a y by dou z. Therefore we consider x component of Lagrange force. Therefore equation 7 becomes Fx is equal to q charge particle q minus dou phi by dou x minus dou a x by dou t plus vy dou a y by dou x dou a y by dou x minus dou a x by dou y minus vy dou a x by dou z minus dou a z by dou x. Now consider vy multiply dou a y by dou x minus dou a x by dou y minus vz dou a x by dou z minus dou a z by dou x, and solving this, and we get vx dou a x by dou x plus vy dou a y by dou x plus vz dou a z by dou x minus vx dou a x by dou x plus dou vy dou a x by dou y plus vz dou a x by dou z. Also we know that dAx by dt is equal to vx dou a x by dou x plus vy dou a y by dou y plus vz dou a x by dou z plus dou a x by dou t. Therefore vx dou a x now see here dou a x by dou t. Now replace this minus LHS म्हणजे हे इकडं मायनस न्या. Therefore dAx by dt minus dou ax by dou t is equal to Vx dou A z by dou x plus Vy dou A z by dou y plus Vz dou Az by dou z, and this is dou by dou x of V bar dot product A bar is equal to dou by dou x of Vx Ax plus Vy Ay plus Vz Az, and dou by dou x of V bar dot product A bar is equal to dou by dou x of Vx Ax plus Vy Ay plus Vz Az. Therefore, dou by dou x of V bar cross V bar dot product A bar is equal to Vx dou Ax by dou x plus Vy dou Ay by dou x plus Vz dou Az by dou x. And equation 10, what is equation 10? This is equation 10. Dou by dou x of V bar dot product A bar is equal to dou by dou x of Vx Ax plus Vy Ay plus Vz Az, and dou by dou x of V bar dot A bar is equal to Vx dou x by dou x plus Vy dou A by dou x plus Vz dou Az by dou y. In equation 9, what is 9? What is 9? This is 9 number equations, and we get simplified form. Vy dou Ay by dou x minus dou Ax by dou y minus Vz dou Ax by dou z minus dou Ax by dou x is equal to dou by dou x of V bar dot A bar minus dx by dt plus dou Ax by dou t, and hence equation 8 can be written as Fx is equal to q into minus dou by dou x of phi minus V bar dot A bar minus dx by dt. Also, dou by dou Vx of V bar dot A bar is equal to dou by dou Vx Ax plus Vy Ay plus Vz Az is equal to Ax. As phi is independent of Vx, therefore we write dou by dou Vx phi minus V bar dot A bar is equal to minus Ax. Therefore, d by dt of dou by dou Vx phi minus V bar dot A bar is equal to minus dx by dt. Therefore, this equation substituting in Fx is equal to q into minus dou by dou x of phi minus V bar dot A bar minus dx by dt, and we get Fx is equal to q into minus dou by dou x of phi minus V bar dot A bar minus d by dt of dou by dou Vx of phi minus V bar dot A bar. Define the generalized potential U is equal to q into phi minus V bar dot A bar. Therefore, equation Fx can be written as Fx is equal to minus dou V by dou U by dou x minus d by dt of dou V by dou x dot. Hence, the Lagrange's equations of motions d by dt of del by t by del by x dot minus del by t by del by x is equal to fx, and the value of fx is minus dou u by dou x plus d by dt of dou u by dou x dot. Therefore minus dou u by dou x replace this is plus, and plus dou u d by dt of dou u by dou x dot replace this is minus. Therefore d by dt of dou of t minus u by dou x dot minus dou by dou x of t minus u is equal to 0. And we know that t minus u is our Lagrangian L. Therefore dou by d by dt of del by L by del by x dot minus del by L by del by x is equal to 0, where L is the Lagrangian and L is equal to t minus u, and t what is 1 by m x dot square plus y dot square plus z dot square, and u minus q pi plus q v bar plus minus q pi plus q v bar dot product a bar. Therefore this is shows that Lagrangian of electromagnetic field. Now we have to show that the Lagranges. Next example, show that Lagrange's equations of motion d by dt of del by t by del by u del by t by del by qj dot minus del by t by del by qj is equal to qj can also be written in the form of del by t dot by del by qj dot minus 2 del by t by del by qj dot is equal to capital Qj generalized force. Solution. Now here the kinetic energy T is in general. Kinetic energy is a function of generalized velocity, generalized coordinate and time t. Therefore we can write kinetic energy T is equal to T of qj dot t. Now we differentiate with respect to time t, so we get dt by dt is equal to t dot. Therefore dou t by dou qj into dou qj by dou t is equal to qk dot, and dou t by dou qk dot into dou q dot by dou t is equal to qk double dot plus dou t by dou t. Again differentiate partially with respect to qg dot. Therefore dou t dot by dou qj dot is equal to dou by dou qj dot into dou by dou qj dot of dou t by dou qk into qk dot. This is u multiply v product rule apply plus dou by dou qj dot del by t by del by qk dot into qk double dot plus dou by dou qj dot dou t by dou t. Therefore this is product rules, u into v rule. Therefore u same as v derivatives of v plus v same as derivatives of u, and we get dou t dot by dou qj dot is equal to dou t by dou qj dot dou qk dot plus dou t by dou qk here delta k I is अगदी स्मॉल व्हेरिएशन आहे, इट इज इक्वॅलन्स टू 1 प्लस डो 2t by dou qj dot dou qk dot qk double dot plus dou 2t by dou qj dot dou t. Again dou t dot by dou qj dot is equal to dou summation over k dou 2t by dou qj dot dou qk dot plus dou t by dou qj plus summation over k dou 2t by dou qj dou qk dot qk double dot plus dou 2t by dou qj dot dou t. Also we find the expression d by dt of dou t by dou qj dot is equal to summation over k dou 2t by dou qk dou qj dot qk dot plus dou 2t by dou qk dot dou qj dot qk double dot plus dou 2t by dou t dou qj dot. Therefore we subtract equation dou t by dou 2 dou t dot by dou qj dot minus d by dt of dou t by dou qj dot is equal to dou t by dou qj. Therefore but we have given that d by dt of d by t by d by qj dot is equal to d by t by d by qj plus qj. Therefore d by t dot by d by qj dot minus d by t by d by qj plus qj is equal to d by t by d by qj, and we get d by t dot by d by qj dot is equal to minus 2 d by t by d by qj is equal to qj, and this is our required proof. Now we have to show that one example. A particle of mass m moves on a plane in the field of force given by f is equal to minus ir cap kr cos theta, where k is constant and ir cap is the radial unit vector. Show that angular momentum of the particle about the origin is conserved and obtain the differential equation of the orbit of the particle. Solution. Let xy and r theta be the Cartesian and polar coordinates of the particle of mass m moving on a plane under the action of the given field of force. Therefore f is equal to minus ir cap kr cos theta. Since the force is explicitly given, therefore hence the Lagrange's equations of motion corresponding to the generalized coordinate r and theta given by d by dt of d by dt of d by t by theta dot minus d by t by theta is equal to 0, and d by dt of t by r dot minus d by t by r is equal to qr, where t is kinetic energy of the particle and is given by t is equal to 1 by 2 m x dot square plus y dot square is equal to 1 by 2 m r dot square plus r square theta dot square, and the component of generalized force along the radial direction and in the direction of theta are given by qr is equal to minus ir cap kr cos theta and q theta is equal to 0. Hence equation 1 and 2 becomes d by dt of mr square theta dot is equal to 0. Therefore mr square theta dot is equal to constant, and mr double dot minus mr theta dot square plus kr cos theta is equal to 0. This is equation of motions of the orbit of the particle. Next example, show that Lagrange's equation of motion can be also written as d by L by d by t minus d by dt of L minus qj dot d by L by d by qj dot is equal to 0. A Lagrangian of the particle is L is equal to L of qj dot t. Differentiate with respect to t. We get dl by dt is equal to d by L by d by qj dot plus d by L by d by qj double dot plus d by L by d by t. Now consider the expression. d by dt of summation over j d by L by d by qj dot multiply d by L by d by qj dot. This is product, therefore u into v rule. qj dot same as d by dt of d by L by d by qj dot plus d by L by d by qj dot same as d by dt of qj double dot. Therefore this equation subtract from the equation 1, t is equal to 1 by 2 m x dot square v plus y dot square, and v is equal to v of xy. Therefore we write d by dt of d by L by d by qj dot minus d by L by d by qj is equal to 0. Therefore equation 3 becomes, this is value of this value is 0, this value is 0. Therefore we get d by dt of L minus qj dot d by L by d by qj dot minus d by L by d by t is equal to 0. This is required form. Next, a particle of mass m moves in a plane under the action of a conservative force with components fx is equal to minus k square into 2x plus 1 and fy is equal to minus k square x plus 2y, where k is a constant. Find the total energy of the motion and the Lagrangian and the equations of the motions of the particle. Solution: a particle is moving in a plane. Let xy be the position coordinate of the particle at any instant t. If t and v are kinetic energy and potential energy of the particle, then we have t is equal to 1 by 2 m x dot square plus y dot square, and v is equal to v of xy. Since the force is conservative, we know that force is conservative, then F is equal to minus delta V. That is Ifx plus Jfy is equal to minus I dou V by dou x plus J dou V by dou y plus K dou V by dou z. What is Fx? Fx is minus k square 2x plus 2y. What is Fy? Minus k square x plus 2y. Therefore, dou v by dou x is equal to k square of 2x plus y, and dou v by dou y is equal to k square x plus 2y. Now, therefore, dv we calculate as dou v by dou x dx plus dou v by dou y dy. Therefore dv is equal to k square 2x plus y dx plus k square x plus 2y dy, and which are integrations. Therefore v is equal to k square x square plus xy plus y square plus xy. Therefore v square is equal to k square x square plus xy plus y square. Therefore Lagrangian of the motion is given by L is equal to 1 by 2 m x dot square plus y dot square minus k square x square plus xy plus y square, and this is our main solution.